Question C. The company decides instead to use a 5% significance test. A random sample of 25 kettlebells is selected and the mean is found to be 16.02. Carry out the test to determine whether or not the new production method will be rejected. Okay, you've got quite a few different possible methods you could do. Okay, I will just show you the simplest one, using the answer from the sample and comparing it to a 5% significance test level. Okay, so you will always start off with H0, which is always going to be mu equals, and H1 is mu, well, not equal to, bigger than, less than. We'll think about what that is in a second. Okay, so our H0 is that mu is still 16. The mean hasn't changed, is still 16 kilograms. Okay, now remember in part B, we were going to reject if it didn't round to 16 to the nearest 100 grams. So that was kind of like a two-tail thing. And the wording in question B also says it needs to check that the mean is still 16 kilograms. Okay, and there's no other wording that's sort of contradicting that. So that means it's a two-tail test, and our H1 is that mu is not equal to 16. Okay, write exactly as that, please. Don't try and change what you're going to write. Don't write mean in place of mu. They want to see the symbol. Okay, just do exactly that process. Okay, so we've got our X bar, we've still got 25 in the sample, so we still have a normal distribution with 16, and our new standard deviation, as we said before, was 0.08 over root 25, which we did work out as 0.016. Okay, so this time we have an answer. The mean has been found to be 16.02. So what we need to do is work out the probability of that. Okay, so here's my 16 in the middle, 16.02 is there. What is the probability of 16.02 or further away from the mean? We're always going to work out a probability that is the tail of the diagram. So here, because 16.02 is above the centre, our tail is going towards the top. So we need to work out the probability that X bar is greater than or equal to 16.02. And you don't have to have the equals bit on the symbol. Okay, it's continuous data anyway. So we need to find that. So if my mean had come out as, let's say, 15.97, I would be working out the lower tail. Okay, because this has come out above the mean, we're going to work out the upper tail of this picture. So again, we just use NCD and we work out this probability. So we've got 16.02 is the lower, and we can just put in a big number for our upper. We've still got our sigma and we've still got our mu the same. So that gives us 0.1056. Now, if this was a one-tailed test, that would be our p-value. Because it's two-tailed, we multiply this by 2 to count the symmetrical two tails. Okay, so if I go back into menu 1, I can just say answer times 2 and it will tell me 0.2113 roughly. So that's our p-value. So that's the probability of our event happening whilst H0 is still true. Okay. Now this is quite a lot higher than 5%. Our significance level we were supposed to be comparing it to. So this is not even all that unusual at all. Normally we say it's unusual, but it's not unusual enough, okay? Or it is unlikely enough. Here, it's not even that unusual. So we definitely do not reject H0. Okay, you only reject H0 if your p-value is below your significance level. Okay, so we can say there is no evidence that the mean has changed. And what does that mean about the new production method? It says the new production method will be rejected if it's obviously going to be, the mean is going to be falling outside, and it's definitely not outside our sort of boundary. So there's no evidence to reject the new production method. Okay, so whether or not the new production method will be rejected, we're not going to reject the new production method. Okay, the other way you could do this test would be to use a critical value and work out in advance what your critical values would be, and then see whether 16.02 falls in there. So let's just quickly show you how that would work. Okay, if you were doing the critical value method, when it's a two-tail, for the critical value, you need to split your percentage into your two tails. So we want 2.5% either side. Okay, obviously if it was a one-tail test, you wouldn't do that step. So what we need to do is find these two values that I've put as little question marks, okay, and we can do that using the inverse normal process. Okay, so if I use inverse normal to find the lower question mark, okay, I'll put my area as 0.025, that's the area to the left of the line. The sigma is our new sigma, and our mu is our 16. So that gives us 15.96, 9697, let's just say 969. And if I do the other end, then 1 minus 2.5% would be 97.5%. So I'd need to take my area as 0.975. And that would give me 16.0313 or 0314. So basically you are going to stick with H0 if you're between 15.969 and 16.0314, and you would reject H0 if you're outside in the tails, basically. Okay, so then if you were doing this process and you'd worked out these two boundary values for sticking with H0, then you would just say, well, 16.02 is definitely within this. Okay, we're not in the tail of, oh my god, that's really unlikely. We're just in this middle bit where we're just saying that's not that unlikely at all. Okay, so again, our conclusion would be we will stick with H0. We do not reject it. Okay, and again, you can always do the Z's. I really don't think there's any need to use the Z formula, okay, and use the standard normal distribution. Okay, but if that's how you want to do it, then that should also work as well.